Hello everyone, I'm physics teacher and welcome to my podcast where I attempt to teach high school physics and chemistry concepts to my daughter in elementary school. Say hi, Coins.
Hi.
Be sure to listen to the end to see how she does on her final quiz of 5 questions, and if you enjoy it and want a second season, let us know. This is episode 5 of 6 where I try to teach her about naming compounds, which in chemistry we refer to as nomenclature. Alright, Coins, so we're going to look at our periodic table. And first we're going to look at where the metals and non-metals are. So do you see this sort of turquoise staircase on the right side?
Yes.
Okay, those are called metalloids. They basically have some properties of metals and some properties of non-metals. Everything to the right are non-metals. So like carbon, nitrogen, chlorine, krypton, all those are non-metals. Everything to the left are metals. It's like aluminum, iron, calcium, potassium. Those are all metals, except for hydrogen. We do stick hydrogen with the metals because it likes to pretend it's one many times. Now, the first type of compound we're going to have is called ionic compounds, where we take a metal and mix it with the non-metal. And naming it is very, very simple. All you do is name the metal, and then you name the non-metal, but you change the ending to IDE. So for example, if I were to take lithium and mix it with sulfur, you get lithium sulfide, changing the ending to IDE. Make sense?
Sure.
All right, so let's try one. What would you get if you took calcium and mix it with chlorine?
Calcium chloride?
There you go.
Oh.
What about sodium and oxygen?
Sodium oxide.
Close. Close. When we change the ending to IDE, what we're going to aim for most of the time is 2 syllables. So instead of oxygen or whatever that was, we're just going to say oxide.
Oh.
Right? So sodium oxide. Let's try another tricky one. How about potassium and nitrogen?
Potassium nitrogide.
Okay, that was 3 syllables.
Nidride.
Close. Nitride. Yes, potassium nitride. Any questions?
No.
All right. Now notice I've only been giving you examples of metals at the left here, either alkaline metals or alkaline earth metals. All the ones...
I didn't notice that.
Oh, okay. Well, now I'm telling you to notice it, so notice it. All of the ones in the middle here are called transition metals. All right, so with the transition metal, we usually, next to the name of the metal, in Roman numerals, we write the charge of the metal. Okay, and we do that because transition metals can come in different varieties, in different charges. Okay, so for example, iron, you can have a charge of +2 or +3. Now these metals gain these charges because metals tend to like losing some of their outer electrons. Non-metals like gaining electrons. This is how this ionic compound forms. A metal becomes positive, a non-metal becomes negative, and opposites attract. But with transition metals, we have to specifically say the charge. So let's say we had iron with a charge of 2, and we mixed it with chlorine. Then we would simply call it iron 2 chloride. We simply state what charge it is. So what would you get if you had iron that had a charge of 3 and we mixed it with oxygen?
5?
What? This is not a math question. So take iron and then you just state its charge. So I already told you it's 3. So you have iron 3.
3.
Okay, iron 3. Repeat after me. Iron 3.
Iron 3.
And then oxygen becomes, same as before.
3?
No, name oxygen.
Oxygen.
Change the ending to "ide."
Oxygen. Oxide.
There we go. So iron 3 oxide.
Yes.
If you want to name that one easier, that's rust.
Oh.
Okay. A lot of metals, when they bond with oxygen, they corrode.
What about water?
Hydrogen is even though we like to consider it a metal, sometimes isn't. So we'll talk about water a little bit later. All right, but other metals like copper. Let's say we had copper with a charge of 1. That would be...
Copper 1.
There you go. And if you mix it with oxygen, you get...
Rust.
Not rust. Rust only forms from iron, actually. Right?
What?
Yeah, so if you have another metal like copper bond with oxygen, that is called corrosion, but it actually, unlike iron, becomes very, very strong. Whereas when iron rusts, it becomes like brittle and breaks off. But a long time ago, I took you to Ottawa, and
You did?
Yeah, you were very young. You probably don't remember, but a lot of the roofs on like Parliament and such used to be like a reddish color because they were copper.
Copper. Yeah, I heard about that before.
And what color are they now?
Blue? Blue?
Like a greenish color, but sure.
Turquoise?
Yeah, like
Teal?
a turquoise color, yeah. And that's because...
Like the Statue of Liberty?
Oh, I don't know if the Statue of Liberty was originally copper. If anyone knows let us know in the comments.
I heard something about the Statue of Liberty being like copper. I don't know.
Was originally copper?
I don't know.
Huh. I don't know. Interesting. We'll have to look that one up. But nobody needs to repair it because like copper oxide or copper 1 oxide is actually stronger than the original metal.
Okay.
Okay. Let's try one more. Let's say we have, let's randomly pick one here. Silver with a charge of 1 and chlorine. What does that become?
Silver 1 chloride.
There we go. Okay, so we got that.
What turned into?
What? I don't know. That's silver 1 chloride. I don't specifically know what that one is. Although I do an experiment with my grade 10s where they take a silver compound and they actually precipitate the silver out, and they don't realize that they're actually like collecting pure silver. And I just tell them to hand it back in when they're done. And we take care of the chemical waste later. But anyways, next we're going to look at polyatomic ions. So this is a chart. Right? Whenever there are certain compounds which have a charge, right? Such as, if you look here, chlorate. Chlorate is ClO3. Okay, it is a polyatomic. Poly just means many atomic atoms, so many atoms. Right? And we can take a metal and combine it with any polyatomic ion. Now, naming it is actually very simple. So if I took sodium and combined it with chlorate, I would simply call it sodium chlorate. That's it. There's no special trick here.
Okay.
Okay. So what would you call potassium that's mixed with sulfate?
Potassium sulfate?
That's it. What about sodium that's mixed with bicarbonate? What would you call that?
Sodium bicarbonated.
Yeah, something like that. Sodium bicarbonate, otherwise known as baking soda.
What?
Yeah.
Huh.
That's baking soda. No, there's also a little pattern here I want you to notice with the oxygens. Here we have ClO3, it's chlorate. If we add an oxygen, so we have ClO4, we get perchlorate. So if we do a per, we've added an oxygen. However, if we took one away and we have ClO3 instead of chlorate, we get chlorite. And if we take another one away, we get hypochlorite.
Okay.
That's just an interesting pattern that I usually tell my grade 11 chemistry students when we're doing this. So that are all ionic compounds where we have a metal mixed with either a non-metal or a polyatomic ion. Now, we cannot take a metal and a metal because you have a positive charge and a positive charge, opposites repel.
Yeah, like magnets. That makes sense.
Oh, we should do a physics lesson on magnets. Oh, you regret asking that.
Who says I regret anything?
Okay. So let's look at nonmetals, because you can take a nonmetal and a nonmetal and combine them together, but how they combined isn't by some sort of attraction between the charges, because they both have negative charges.
Okay.
But nonmetals want electrons, right? Nitrogen wants electrons, oxygen wants electrons, fluorine wants electrons. So what they do is they get together and say, well, why don't we share electrons? And that is called a molecular compound, right? If they're sharing electrons, it's called a molecular compound. So take hydrogen and oxygen. That's a molecular compound. They're two nonmetals. Take carbon and oxygen. That's a molecular compound. Now, when we're naming molecular compounds, we're still going to change the last element ending to IDE. It's still going to be changed to "ide." But I need to specifically tell you how many atoms there are.
5?
Well, no, I'm not. We're not randomly guessing. What do you think the difference is between carbon monoxide and carbon dioxide?
Monoxide and dioxide.
Okay, the mono and the di. Do you know what they mean? What if I were to say tri? What do you think that would mean?
Try again.
No, like tri as in triangle. How many sides does a triangle have?
3.
3. Do you know what a quadrilateral is? Have you learned that in math?
Sure.
It's a shape that has how many sides?
4.
Okay. Right. Now in chemistry, mono means 1, di means 2, tri means 3, and then 4 and 5 would be tetra and penta.
What? Why they change it? Why they can't just call it 1, 2, 3, 4, 5, 6?
I don't know. Right. So for example, carbon monoxide, these are called prefixes. So when we say monoxide, it means 1 oxygen atom. Carbon dioxide means 2 oxygen atoms. Now there's only 1 carbon, because I never said dicarbon or tricarbon. And we never put mono in front of the first one. It's just always assumed if you don't have anything else. So carbon dioxide, which is the stuff we breathe out, would be C, and then O2.
Oh,
Carbon monoxide
is something that kills you?
Yep,
That's
it's very
why-
dangerous.
Why don't they use die at the end then?
Okay. Haha. I'm supposed to be the one saying the puns here. Okay. Okay, carbon monoxide is just CO. Now, what do you think NO2 would be called? So we have nitrogen and then O2. How many oxygen?
2.
Okay, so what's the prefix for 2? Is it mono?
No, die.
Di. So it's nitrogen, di,
Oxygen.
oxide. We're still changing the N to ID. Okay, so nitrogen dioxide. Now, if we take hydrogen and mix it with chlorine, what would that be? 1 hydrogen, 1 chlorine. So you start with hydrogen.
Hydrogen chloride.
How many chlorine?
1?
1. So you actually are right. It's hydrogen chloride. But usually my grade 10s will say hydrogen monochloride, which I accept. But typically chemists will say hydrogen chloride.
Because it's shorter and they're lazy?
Maybe, yeah. Well, because they like to think of hydrogen as a metal, so they use the rules of ionic compounds. But now the interesting thing comes. If we try to take hydrogen chloride and dissolve it in water...
Then it dies?
No, they split into hydrogen ions. Remember, ions are charged particles, and chlorine ions. And when we have hydrogen ions inside water, we have an acid.
Okay.
So now, when we take hydrogen chloride and dissolve it in water, we get an acid. So how are we going to name this acid? Because all acids have hydrogen, we're going to start with hydro. We're not going to say hydrogen, again, lazy. Hydro. And then we're going to change the ending of chlorine to chloric. We're going to change the ending to IC. And then we're going to say acid. So hydrochloric acid.
Oh, I've heard that before.
Yep, it's a popular one. What about if we were to take hydrogen and mix it with fluorine So you have hydrogen fluoride.
Hydrofluoric acid.
Perfect.
Oh my god, I'm so smart.
There you go. Now this is called a binary acid.
Okay.
Binary meaning two things, hydrogen and fluorine. Now there's another type of acid where we're going to mix polyatomic ions. So let's go back to our list here. Take
Ammonium.
chlorate. Take chlorate because we were talking about chlorate before. Now we mix it with hydrogen. Get hydrogen chlorate. But now we're going to dissolve it in water. Now this one has oxygen in it. So this is called an oxyacid. So we're going to name it slightly different. We're not going to say hydrochloric acid because that's HCl. Right? So instead we're just going to get rid of the hydro.
Chloric acid.
That's it. Chloric acid. So if there's no hydro in the beginning, it means there's an oxygen there. And it's an oxyacid. If there is a hydro, there's no oxygen, it's a binary acid.
Okay.
Okay. What if I were to take hydrogen and mix it with nitrate and dissolve it in water? What do you get?
Hydronite. It axes.
Okay.
Wait, let me try again. Stop.
Okay.
Let me try again. Hydronitric acid.
Okay, so the nitrate becomes nitric. But do
You tricking me?
No. But is there oxygen?
No.
Look at the formula for nitrate.
Where is the formula?
Right there.
There is oxygen.
So do we say hydro?
No.
So what's it called?
Nitrate acid.
There you go. Nitric acid. Okay. Ready for your test?
Easy.
Sure. Okay, it's going to be hard. You have 5 questions. Each has 2 parts.
I'll get perfect. Don't
okay.
worry.
This is hard because I've gone over a lot of stuff. So if I take sodium and combine it with chlorine, what's it called?
Sodium chloride?
Yes, sodium chloride. Is that an ionic or a molecular compound?
Ionic.
All right.
Haha, big brain.
First question right. Next question. If I were to take iron with a charge of 2, and mix it with oxygen, what is it called?
Iron dioxide.
Close, but no.
Stop, no. Okay, let me try again.
The monodi you only use with molecular compounds when you have non-metals.
Iron oxide.
Close, but you're missing...
Iron oxide. Fat oxide.
Iron 2 oxide.
What?
You have to state the charge.
No. What? That's bull. That's no.
Oh, well, you can still get half a mark. Is it ionic or molecular?
Mark. I want a full mark.
Is this ionic?
Molecular.
No, okay, you didn't get any marks.
I get a full mark.
No, you got no marks for that one. If it has a metal, it's ionic. If it doesn't, it's molecular. All right, moving on to the third question. What do we call it if we have 1 carbon and 2 oxygen?
We didn't talk about this. This is not fair.
We did talk about it. We did. Don't worry. Usually I teach nomenclature a little bit in grade 9, over a week of it in grade 10, and then a week of it in grade 11. And we're covering it in like 15 minutes. So don't worry about it. Okay. First, is it ionic or molecular?
Ionic.
No.
Bro, no, rewind. Okay. Molecular.
Remember the rule. If it has a metal, it's ionic.
A molecular.
So you look, carbon is here, oxygen is here. Are either of those metals?
No.
So,
I said molecular at the start.
Molecular? Okay, molecular. If it's a molecular, you have to use mono, di, tri prefixes.
Okay, this is easy, okay?
So C and then 2 O's. What's it called?
Carbon dioxide.
There you go.
Easy.
There you go. All right, we'll give you that one.
I have 3. What are you talking about?
No, number 2 you didn't get. But don't worry about it. Most students hate transition metals the most. Okay, next. If you take hydrogen and chlorine, combine them, and then dissolve it in water.
Oxy.
Okay.
Oxyacid.
Well, I haven't even asked the question yet. Is it binary or oxy?
Oxyacid.
No.
What? Binary acid. That's what I said.
Yes. Remember, oxyacid has oxygen.
What?
Oxyacid has oxygen.
And
So
water is in.
if you
oxygen is
just
in water.
So remember, if you have oxygen, it's an oxyacid.
Is it because like water has oxygen?
Okay, no, you don't have to. That's a good question. Okay, water does have oxygen, but we're only looking at the compound that's dissolved in water. So you take hydrogen and chlorine, which is hydrogen chloride. Is there oxygen in hydrogen chloride?
Sure. Yes.
If you have hydrogen and chlorine, where's the oxygen?
I said no.
What two elements do you have?
Hydrogen and chloride?
Yeah. So is oxygen one of those?
No.
No. So is there oxygen?
No.
So what is it? If I take that and dissolve it in water, is it binary or oxy?
Binary.
Exactly.
Okay.
So if it's binary, what do you call it?
Hydrogen chloride?
That's what you would call it before dissolving it in water. But when you dissolve it in water, it becomes an acid. So what's the name of the acid?
Hydrogen chloric acid.
Very, very close.
Stop! No. Stop. Hydrochloric acid.
There you go. Okay.
I got it.
Okay.
Easy.
You ended up getting that one. All right. Last one. If we take hydrogen and mix it with chlorate, which is ClO3, is there oxygen?
Yes, it's oxyacid.
Okay. And if you then dissolve it in water, what's the acid called?
Chloric acid.
You got it.
I got it. Oh my god.
All right.
I'm smart.
Good. All right, we got one more episode that we'll do later on moles and stoichiometry.
Huh?
But don't worry, I think this was going to be the hardest lesson because usually I teach this over grade 9, 10, and 11. And then grade 12s, they do naming organic compounds, but we're not going to go that far. All right, good job.
Thank you.
4 out of 5.
What?